In 9.4, we are solving rational equations. So before this section, we've been working with expressions. Now expressions are just, fractions, rational expressions, right? We don't have any equal sign. Now we have an equal sign involved, right? All these are equal sign. And also notice we're talking about solving, right? So whereas before we were just simplifying the expressions, now we are solving the equation. So our final answer for all of these should look like x equals some number. All right, so that's going to be our answer. Now, if I look at the first one's not a really a rational equation, but it is a fraction equals a fraction, which we know is called a proportion. Now, when we solved proportions way back when, we said that one method we could use is called cross multiplication. And so method one, all right, this is the first method of solving these, is to cross multiply. All right, now this method works great whenever you have a fraction equals a fraction. Notice fraction equals a fraction, fraction equals a fraction, down here, fraction equals a fraction. In these later ones, it's not gonna work so well because we've got a fraction equals a bunch of other stuff, right? So I gotta kind of adjust and do that a little bit different, all right? So what we're gonna do now is go ahead and solve this. So kind of going back from the basics here, just a simple example. But when I cross multiply, x times 15 is 15x. And then 5 times 8 is 40. So we've got that 15x equals 40. And that's where that comes in. And so now that I know that 15x equals 40, we can go ahead and divide both sides by 15. And that gives me x equals 40 over 15. Now I can divide both of these by 5. So that's going to give me x equals 8/3. And that's going to be our final answer. All right. If the teacher writes, or somebody asks you to write it as a mixed number, you can go ahead and do that, or a proper fraction, that's fine as well. But I'm okay with it being like this, right, as an improper fraction. One common mistake that I see is people, when they do the cross multiplication, is they kind of keep it as a fraction. They almost do like x times 15 is 15x, and then 5 times 8 is 40, and they kind of write it like a fraction like that. Please don't do that. You can't just get rid of the equal sign, right? You can't just turn an equation into a single expression, so don't get rid of your equal sign. Make sure you write it as one cross product equals the other cross product, kind of like what we did there. So now that we've got these rational expressions here, we're going to do exactly that. We're going to go ahead and cross multiply. So x times x plus 11. And then we've got our equal sign. On the right side, we're going to do 3x times 2x minus 3. And of course, it doesn't matter which side you do these on. I could have done this side in red and this side in blue. It doesn't matter. You can do it either way because, again, if you think about an equation being like a scale, it doesn't matter if I have, 10 pounds of gold and 10 pounds of feathers. They could be on either side. They're still 10 pounds. They're still going to be equal to each other. So it doesn't matter which side you put them on. I then will have to distribute. So that's going to give me x squared plus 11x equals, when I distribute this, we've got 6x squared minus 9x. All right. So now I'm going to want to go ahead and try to solve this. And it looks like the best way to solve this might be to maybe get everything on the same side, right? We have a quadratic, so typically it's best to set this equal to 0. So I'm going to try to subtract 6x squared on both sides. And that's going to cancel over here. I also want to move this to the other side, so I'm going to go ahead and add 9x. Again, trying to set these equal to 0. So now I'm going to have negative 5x squared plus 20x equals 0. Now this is one of those problems where I actually can just go ahead and take out a GCF. And so if I divide both of these by negative 5x, that would leave me with x minus 4 equals 0. And at this point here, I'm going to go ahead and see what each of these answers are going to be, right? We know that I have to have two answers. It's quadratic. So on the one hand, x could be 0 if I plug in a 0 here. On the other hand, x could be 4 if I plug in a 4 here. Now you can get extraneous solutions here. So you do want to plug these in and check for extraneous solutions. So if we go back to the original and we plug in a 0, that would be 0 over, well, if I plug in a 0 here, that's just 0 minus 3 is negative 3. If I plug in a 0 on the right side, 3 times 0 is 0, and then 0 plus 11 is 11. Well, yeah, this is still true, right? Because 0 equals 0. So we do know for sure that 0 is a correct answer. And then we're going to go ahead and we're going to try to plug in the 4. And so if I plug in the 4, we get a 4 over, well, we know that 2 times 4 is 8, and 8 minus 3 is 5. On the right side, 3 times 4 is 12. And on the bottom, if we plug in a 4, 4 plus 11 is 5. Sorry, 4 plus, jumping ahead, 4 plus 11 is 15. And so we can see that 12 over 15 does in fact reduce, if I divide the top and the bottom by 3, to 4 over 5. So this is also a true statement, and that means that x equals 4 is also a good answer, okay? But sometimes when you plug them in, it is possible that both work, it's possible that only one works, and it's possible that neither work. So you do want to always plug in your answer and double check, all right? I have the answers here that I've already done these problems, so I'm not gonna, when you're doing the problems, when you're doing the homework, the review, the classwork, everything, I'm assuming you're checking your answer, but I'm gonna already have the answers checked because I already tried these. So next problem we wanna do is 1 over x equals 2x minus 21 all over x squared. So I'm gonna try the cross multiplication method. So I've got 1 times x squared, well that's just x squared. And then on the right side, I'm going to have x times 2x minus 21. So when we distribute everything, that gives me x squared equals 2x squared minus 21x. At this point here, I'm going to try to set it equal to 0. So I think I'm just going to try to move these x squareds over here. And if I subtract x squared on both sides, these will cancel, leaving me with 0 equals x squared minus 21x. At this point here, we can take out a GCF, and so we take out the GCF of x, leaving me with x minus 21. And so again, I'm looking for the two possible answers. We see that here x could be 0, and we see that here x could be 21. All right, so when you plug in these numbers, if you plug in a 21, you should find this to be a true statement, so this will work out. However, when I plug in the 0, notice I get 1 over 0. Well, we already have a problem because you can't divide by 0. Oops. Can't divide by 0. That's not allowed. All right, in case you forgot about dividing by 0, 0 divided by some number is okay, right? That just equals 0. But if you have a number divided by 0, that is not allowed. That's no solution. Sorry, not no solution. We're going to say undefined. Okay, so because I can't divide by 0, this is not going to be one of our answers. That's an extraneous solution. All right. Next type of problem, notice we're not going to use the cross multiplication anymore because I have two terms on the left. So in this method here, I want to use method 2. And we're going to say that in method 2, we are going to multiply every term by the LCD. Remember, the LCD is the least common denominator. So that's the group of terms, the product of terms that's going to give me a common denominator across everything. So if we look at this example, which we've done before, something like this, well, I want to get the LCD to be the same, and I can see that the LCD would be 10. So I want to get all these terms multiplied by 10. So basically, I'm going to multiply this term by 10, this term by 10, and this term by 10. Now, once I do that, I'm going to see a lot of canceling out. So basically, I've got 10x over 2. We know that 3 times 10 is just 30. And 4 times 10 is 40 over 5. Well, I can reduce all of these, right? 10 over 2 is just 5x plus 30, and 40 divided by 5 is 8. So notice all my fractions go away now. I have no more fractions. And honestly, typically what you're gonna see me do in the next couple problems is before I write these out as fractions, I'm just gonna reduce it on the spot. I typically find it's easier to reduce first. So like 10 over 5 is just 2 over 1. And we know that 4 times 2 is 8. Same idea over here. 10 divided by 2, well, we know that 10 over 2 is just 5 over 1, and that's why we had a 5 over here. So I'm going to reduce first because I like to work smart, not hard, so I'm going to typically reduce anything that I can right off the bat. At this point here, we're going to go ahead and subtract 30 on both sides. We end up with 5x equals negative 22. I'm going to go ahead and divide both sides by 5, and we get negative 22 fifths. All right, that's going to be your final answer. If you check that, that does end up working out for us, so we do have a good answer. And that's kind of in general what we're going to have to do here. All right. Now, obviously, that was a little bit easier because now we have some variables in the denominator. And luckily, in this case, we can see that they're both in x minus 2. This one is just a denominator of 1, so I'm going to have to, anything times 1 is itself. So I know the LCD is just x minus 2, but that means I'm going to have to multiply every single term by x minus 2. So I'm taking my original term, that 5x over x minus 2, and I'm multiplying that by x minus 2. I still have the equal sign and the 7, and I'm going to multiply that by x minus 2. And then I have the plus 10 over x minus 2. And same with that, I'm going to multiply that by x minus 2. Okay? Again, this is an equation, so whatever I do on the right, I have to also do on the left. Right? If I multiply the left side by x minus 2, then I have to multiply the entire right side by x minus 2. That's how equations work. So if I look for what cancels, I can see an x minus 2 on top and bottom will cancel. Same thing here, numerator, denominator, those will cancel. That's just equal to 1. So now I just have a 5x. When I distribute this 7, that gives me 7x minus 14. And then because the x minus 2 is canceled there, we have a plus 10. All right. So now I'm just going to try to solve this. We don't have a quadratic, so I don't need to try to set it equal to 0 or anything like that. We can just go ahead and solve. So at this point here, we're going to go ahead and let's see, we can kind of combine these like terms here. And then I'm also going to subtract 7x on both sides. So at this point, we've got negative 2x equals negative 4. And if I divide both sides by negative 2, we get x equals positive 2. So we get an answer of 2. And we should make sure we double check this answer to make sure it works. So if we plug in that 2, I can kind of see I'm going to have an issue, right? If I look at this first fraction here, we get 5 times 2 over 2 minus 2, but we are definitely going to have a problem here, right? We know that we're going to get an answer of 10 over 0, but that is an issue because you cannot divide by 0. So x equals 2 does not work. That means that this problem has no solutions. All right? No solutions to this problem. All right, that means that there's no value for x that you could plug in that would ever make this a true statement. Problem 2. 3 over x plus 4 fifths equals 7 over 2x minus 5. So in this one, I want to identify the LCD. This is a little, not trickier, but there's more going on, right? If I look at the LCD, we know that we have to have an x. All right, this is not factorable. This 2x minus 5, I can't factor that. So there's nothing I can't take out an x or a 2 or any other number. So I definitely need an x in the denominator from here. We also know that we're going to need a 5. So I'm going to have an x. I'm going to have to also have a 5. And I'm also going to have this over here, which is a 2x minus 5. All right, so because they're all different and they don't have anything in common, that means I'm going to have to get all of these terms multiplied by x, by 5, and by 2x minus 5. So we got a little bit of work to do. I'm going to take this 3 over x, and I'm going to multiply it by the LCD. All right, so again, all of this, right, all that. I'm going to write this as times 5x times a 2x minus 5. I'm going to do a plus 4 fifths. And again, I'm going to multiply that by 5x times 2x minus 5. And then that's going to equal 7 over 2x minus 5. And again, I'm going to multiply that by 5x times 2x minus 5. All right, so again, all I've done so far is I've copy-pasted this original right here. I've just copy-pasted, and I've multiplied every single term by the LCD. Now, the reason, again, why this works so well is because you're going to notice things cancel out. I have this x and that x cancel out, the 5 and the 5 cancel out, and the 2x minus 5s cancel here as well. So I'm going to do a little bit of distributing. We know that 3 times 5 is 15, so I've got 15 times 2x minus 5. Here we've got 4 times x is 4x, so plus 4x times 2x minus 5. And then that's going to equal 7 times 5x is 35x. All right, at this point here, we're going to go ahead and want to distribute. And if I distribute, we've got 30x minus 75 plus 8x squared minus 20x equals 35x. All right. At this point here, we do have a quadratic. So again, our best strategy is probably to set it equal to 0 and see if we can solve from there. Let's go ahead and if I move this 35x over to the left using subtraction, let's see what we get here. Minus 35x, minus 35x. These cancel on the right, leaving me with 0. Now at this point here, we do have an 8x squared. 30 minus 35 is negative 5, but I also have a negative 20. So negative 5 minus 20 is negative 25x. And then I also have a negative 75. So at this point here, we've got 8x squared minus 25x minus 75. And we are trying to factor this and see what the solutions are. And if we factor this, again, I'm not going to do this. I've already got this written out. So when we factor this, factor, we end up with x minus 5 times 8x plus 15. If you're not sure how to factor that, make sure you go back to chapter 5 and review all those problems. We also did this in the beginning of this chapter, so make sure you go back and review that. Now, so I'm going to get 2 possible answers. We're going to go ahead and get an answer of 5. So x equals 5. And the other answer is going to be negative 15/8. All right, those are going to be our 2 possible answers, okay? Now, whenever you get fractions like this, I'm not going to make you plug them back in and check. This is going to be kind of complicated, right? If I plugged in a negative 15 over 8, that'd give me a kind of messy solution. So I'm not going to make you test these out, but I would make you test out something like 5. 5, if we plug it in, it does end up working. So that's kind of what I care about for right now. If you ever get any answers that are fractions, you can assume that they work. So I'm not going to make you plug in fractions into fractions. The goal here is just to focus on, can you actually solve these? If you do get a nice number, like 4 here, I would expect you to be able to plug that in, but I'm not testing you on your knowledge of complex fractions. We've already done that. So for this one, we're just going to assume for the sake of saving some time that these are both solutions. All right, but the 5 does work. I would expect you to plug that in and check your answer there. Last one. Again, I want to get common denominators. And if I look at this denominator right here, I see that this is really a difference of squares, x plus 3, x minus 3. All right, so that is useful because now if I think about the LCD, I know I'm going to have an x plus 3 because there's an x plus 3 here. And I know I'm going to have an x minus 3 because there's an x minus 3 here and here, right? So because I have an x minus 3, this actually takes care of both of these denominators. But again, you really want to make sure you're factoring that denominator first to see if you can get any common factors there. Now this is a negative 2 over 1, so we have to include a 1, but we know that 1 times anything is just itself, so that's not necessary. So if I multiply everything but by x plus 3, x minus 3, we've got 12 over x minus 3 times x plus 3, x minus 3. Then we've got a minus 2, and we're going to multiply that by x plus 3, x minus 3. And then we've got equals 40 over x squared minus 9. And we're multiplying that by x plus 3, x minus 3. All right, so again, same process we've been doing. Now I want to cancel. So I see that the x minus 3's cancel here. Nothing cancels here. I'm going to have to distribute all of that. And then we know that x squared minus 9 is the same as x plus 3 times x minus 3. So my new equation right here, when I distribute the 12, we've got 12x plus 36. Then I've got a minus 2, and we know that this is really x squared minus 9. And then that's going to equal just a 40. If I just FOIL that negative, or multiply that negative 2 with distributing, we've got 12x plus 36 minus 2x squared plus 18 equals 40. And now I'm going to go through that same process of trying to factor this. All right, so if I combine like terms and try to move this 40 over here using subtraction, minus 40, we end up with negative 2x squared. We have a positive 12x. And if I look at all the numbers, we know that 36 plus 18 is 54. And 54 minus 40 is 14. All right, so for something like this, I would say we can maybe take out a GCF of negative 2. So we take out a negative 2. That gives me x squared minus 6x minus 7. And that's definitely a little bit easier to factor now. So if I look to factor this, I'm looking for two numbers that multiply to negative 7 and add to negative 6. And that's going to be x minus 7, x plus 1. And then we're going to go ahead and get answers of 7 and negative 1. All right, we just want to plug those back in and check. And I'm going to make you do this. All right, the last question is going to be, is 7 the answer? Is negative 1 the answer? Are they both answers? All right, so you're going to have to take these two answers that we just got and plug them back in into the original equation and see if they're true or false. All right, that's going to be the last question.